So good morning. And welcome to the ICES Connect, the first Icelandic fisheries webinar and exhibition series. My name is Vilhjálmur Jens Árnason, usually called abroad William. And for the last 10 years, I've been working as a project manager at the Iceland Ocean Cluster and as an independent advisor. Before that, I used to work for the Federation of Icelandic Fishing Vessel Owners, Trade Council of Iceland, and the Icelandic Freezing Plants Corporation. At the Ocean Cluster, the increased utilization of marine resources is of huge importance for us. And we put a lot of emphasis on all work associated with increasing utilization, and our goal has been to achieve 100% utilization of marine resources. And this is, of course, of huge importance. It's not only something that is economically viable and beneficial for those who are utilizing the resources. It is also of huge importance for environmental purposes and so on. And we've been watching this conference in Glasgow, COP26, and a part of the solution when it comes to the climate change is to reduce waste, because food waste is a huge problem when it comes to climate issues. And it is, according to figures I've seen, approximately 8% of our emissions that we get are associated with methane that comes from landfills where you have food and so on. Today, our session will focus on how to we push the industry to maximize the processing output, and how we can encourage the use of all parts of the fish. And we have along with us specialists that are providing solutions to increase utilization. We have Frode Blålid from the company Nuas Technology. We have Dennis Lohman he is the head of product management from Bader. And we have Mehdi Abdullah, which is a researcher at Chalmers University of Technology in Gothenburg in Sweden. Today we will have a very set time limit, so we are supposed to finish here at 11. So I think it's just wise for us to give the floor to the speakers. But I want to advise all of those who are watching this that the session is being recorded. But it is important that we get participation from those who are watching, and it is possible to send questions to those who are speaking, the participants. And everyone is, of course, welcome to ask questions to the panel. And if you have entered the program, you can find the question button or the feature next to the chat function. So you can type in any questions through the event, and if you're and it would be really nice if you could direct the question to a specific speaker, and by providing the speaker's name and so on. For those who are using mobile phones, it should be possible to use the function, but the function may be hidden and can be accessed by clicking a blue speech bubble icon, if I'm correct. But I think it's really important to just start the discussions and give the floor to the speakers. The first speaker is Frode Blålid. He has a background from sales and management in the logistics industry, and he is one of the founder of NUAS Technology in Norway. And this is a company that has developed a new process technology for hydrolysis of residual raw materials, and this innovation is ready for test production and market launch. And so I think it's time to give Frode the floor. Thank you very much.
Thank you, William. Thank you for the introduction and the invitation to talk about NUAS technology. NUAS technology was established in 2015 in Rissa, outside of Trondheim in Norway. And as William told you, we have developed a hydrolysis process that converts residuals, raw material, into biomass and into marine ingredients like oil, bone, and protein. And we have all built this for human consumptions. And we're now ready to launch it for the new technology into the market and start test production. Our value proposition is to give seafood processing companies better margins through better utilizing of the residuals. Many of them are already have a good good treatment of the residuals, but we believe that it could be even better. We have to treat residuals and byproducts like food through the whole value chain. We also see that there is a global market out there that have an increasing need of sustainable marine ingredients. And we believe that this industry, this fish industry and this ingredients industry is a part of the solution. What you see in the picture here is our full-scale pilot plant with a capacity of 2 tons residual per hour. The process line is mounted into containers. The whole hydrolysis process is mounted into 5 standard shipping containers. That means that it is a mobile solution, but it might as well be mounted into a factory for more long-term production. These pictures is taken from our workshop outside of Trondheim, but we are now ready to move it into a fish processing plant for a long-term test production. The picture in the middle is taken from the second floor in the hydrolysis container, showing the vertical hydrolysis column. The vertical column secures a gentle flow of biomass from chamber to chamber in an energy efficient manner. There are several innovative solutions in this process, and that's how we are being able to patent it globally. It's a control process where we secure that the biomass that enter the process first also will be end the process first. We insert nitrogen to each chamber, both to avoid oxidation, but also to secure a gentle stirring without any mechanical parts. In this model, you may see that we start the process on the left-hand side with a grinder and our own developed heat exchangers. We start after the heating process up to hydrolysis temperature. We start filling the top chamber, and when that one is full, we open the valve in the bottom of the chamber to let the hydrolysis run down to the second chamber. We close the valve again, and then we start and we continue to fill the top chamber. When the top chamber is full again, we open the bottom valve and let the hydrolysis run down to chamber 2 and 3. and so on. We reach the bottom chamber, the sixth chamber, and there, when we reach the sixth chamber, we have had a hydrolysis process for approximately 1 hour. In the bottom chamber, we also might take out the biggest bones that we don't want to take into the separation process. After the hydrolysis process, we go into a second heat exchanger that will take the temperature up to around 90 degrees to stop the process and to have it into human consumption grade, food grade regulation. After this process, we go into the separators where we have 3 phases. We will have oil, and we will have protein water, and we will have solids. The oil will go into oil polisher, and the protein water will go into evaporator to make a protein concentrate, a hydrolyzed protein concentrate. As you can see, as I told you, 5 containers. It also contains another container for evaporator and a steam boiler. So it's quite area effective, about 100 square meters. You have the footprint of the whole hydrolysis process and the height of approximately 8 meters height. We also have our own container for air cleaning before it is up to the air. We are looking into several markets for newest technology. One of them is technology. We want to sell or lease out the technology and the process plant to clients. We are looking also into that joint ventures with the clients might be a possibility. The process industry, both for fish and meat, is the main target for us. But we also believe that the design of the column is quite suitable for onboard processing. And that's one of the key factors for newest technology to handle the residuals when it's fresh or properly frozen. We don't insert any acids to the hydrolysis. We have an export market. Of course, we are focusing on Norway first, but we're already in discussion with some international players. And we also want to test the column and the hydrolysis process on other type of raw material, not only fish and meat. The other market we are looking into is the ingredients market. We want also to develop good ingredients to supply the business market. And we believe that it's important for a company like us to be able to survive or to have good margins in a feed market. That's probably the easiest market to get into in the start, but we have to have good margins also there. But of course, we are looking into both pet food and the food grade ingredients and food grade food, where there might be better margins for us. And in the future, perhaps we also be able to enter the pharmacia market, but that's not the market we have in focus in so far because of the heavy regulation that's in for the pharmacia. So we are interested in have discussions and come in dialogue with both companies that want to develop their own hydrolysis process and suppliers of raw material that might be interested to start a discussion with us to how to handle the residuals in best way manner. So with that, I would like to thank you for the opportunity and looking forward to hear from the other speakers. Thank you.
Okay, thank you, Frode, for a very informative presentation. I was wondering, I may have missed it just in the beginning, but I was wondering what type of raw material would you know, in this process, what is the type of raw material that is the best raw material in terms of course, marine products?
We have been focusing on that it should be a flexible solution, a flexible technology. So it might we are looking into both, for instance, salmon, whitefish, actually anything that have protein and oil in it.
Okay.
So you might have several markets that want, for instance, a good protein. That perhaps whitefish is the best solution. Ones that want omega-3 and fatty acids, maybe another species should be quite suitable. But we are quite confident that the technology will handle different kinds of species.
And you've done some experiments with different types of species.
We have done some lab tests and some industrial tests on for salmon and herring and codfish. But we're now entering a phase that we want to have a test production over 6 months. That we could have more long-term testing. That will give us the answer that the technology is that good that we believe it is. I hope it is.
Yeah. And the raw material that you put in, it must affect the material that is then fully processed material. Do you find a huge difference between or do you have any research that shows any difference between the different types of raw material to put into the processing and then the raw material, how it affects the raw material that you take out of the processing?
That's one of the things we have to test. We know there are differences, and we also have to decide what kind of enzymes will be the best for each species. And one like herring, for instance, is a difference between a herring in the spring and a herring in the autumn. So we have to have good receipts that we are sure that we can deliver the same product every time, even if the species, even if there have been some differences in the raw material. But for instance, we might run on salmon residuals one day and perhaps codfish or herring the next day. The washing process we have a SIP washing system installed, and we might wash down the system after 1 hour or 2 hours. We can have a new production with a new kind of species. So hopefully it will be a technology that can be used by many kind of processing plants. But the key factor is food grade and fresh material.
Very good. Okay. And do you find that there's a huge interest in this technology in Norway?
Yeah, there have been some interest. We have not done that much marketing, but there's interest. Yes, it's more and more people occur that the raw material might be even better margins than the main product. And it's a growing
thank you very
market.
much, Frode. Very informative. And now we'll move to the next speaker, and who is Dennis Lohman. He is head of product management at Bater. He and his team have been focusing on the development of new sales opportunities, and where they have been focusing especially on full utilization of marine raw material, and they are, as we at the Ocean Cluster, very occupied with the idea of getting 100% utilization, and to ensure also that we will have zero waste. But I think we're interested to hear your views, Dennis, and thank you for joining us. The floor is yours.
Thank you very much. Good morning from Lübeck in Germany. My name is Dennis Lohmann, and I'm head of technology management for Bader. Bader is one of the global players when we talk about seafood processing equipment. And today I will show you our view from the bridge, how we see the world of co and byproducts. The title today is Towards Industrial Implementation of Innovative Food Processing Concept for 100% Utilization. This is a long title, but what is behind is, at least I will show you a project what we have done, where we have taken two different co-products. We have used 3 well-known processing steps and create 2 and more high-value end product out of it. Follow me on this road, and I will go shortly to introduce ourselves. And when I mean ourselves, this is a joint project from BARDA and GEA Westphalia Separator. This is also a giant in food processing equipment, and we both together work on this project. Then I will show you our status quo, how we see the world at the moment, the potential of adding value. Then we will add some value, and at the end I will make a conclusion and an overview how we want to go on. We as BARDA, we are a global player in food processing equipment, and as you see, we are home all over the world. We have different processing areas and factories, and our headquarters is in Lübeck in Germany. We are still family owned, and we have more than 100 years experience in this business. And seafood is not the only business where we are. We are also home in poultry processing in BARDA Ring. What this is, I will explain you a little bit later. In business solutions, this is all around complete factories, what we need, and more in digitalization, what get home in our portfolio. How we see the world at the moment. We able at the moment to create approximately 50% yield out of a normal fish. This depends on fish species, quality, size, and so on. But at least 50% we are able to create in main products. And we see that most of the co-products are not utilized in the way as it can be. So there are much more opportunities to get higher value products out of co-products. And when we try to find a solution, we have a kind of roadmap. First of all, we try to keep most of it on the main product. And when we can't reach more and we see a limit in yield, throughput, and automation degree, then we start to think about how we can use the co-products in a better way. That can be that we're already doing the processing, define new co-products and prepare them for further use. And after this, check which co-product is possible to bring to a higher value end product. And one example we go through now. This is a standard filleting line from us. So raw material, in this case, gutted head-on fish. We will head it, we will fillet it, we will trim it, we will pull the pin bones, we skin the fish, and afterwards we can pack it. It's a standard process. It's more or less automated, and we run a huge amount of fish each day. The co-products, what we see here are skins, trimmings, frames, and heads. Let us take trimmings and frames for our example. And when we take a look closer to the fish, in this case salmon, then we see that 12% of the fish ends up in frames and trimmings. And when we make an even closer look to the frames, then we see that 15% of the frame, it's the highest meat you can get out of a fish, but we can't bring it to the main product. So what should we do? We take this product and bring it directly in the bartering process as promised. The bartering process are separators, and these separators works like you see here. We bring raw material in on the right side and we press it between the drum with holes in and a belt. And the result is that in the middle of the drum we get minced meat bone-free out, and on the left side you get the harder part, the bones out, meat-free. So that means we create two different products. We create bones, meat-free, and boneless fish meats. A relatively wet, oily, constant, what you get out of it. But we want to more added value on these products. So what should we do? We take the boneless fish mince. We use a decanter or centrifuge depress unit, however you want to call it. So we press the oil water content out of it. And then we create into this decanter depress unit again two different products. One is a de-oiled fish meat. This fish meat you can sell for a higher price. You can use it directly for human consumption, for burger, whatever. And the liquid phase, what you get out of it, is a mix out of water, oil, and other components. But up to 90% of this liquid phase is oil. And then when we now use a centrifuge or a Gea Westphalia separator, then we can create out of this a high value cold pressed fish oil. And when we take a closer look to the oil content, you see that we have approximately 21% oil left in our first boneless fish mince. When we use the depress unit, then we can reduce it to 10%. And we create this liquid phase, and in this case it was 86% oil content inside this liquid phase. The session is called Technology Innovation. So here I need to say we not really have developed technology innovation. This is more an process innovation, let me say it in this way. We have used well-known technologies, what's already used in a lot of different other applications. But we have managed to bring them in line, to bring them in the right sizes, in the right conditions, and we don't need to add anything to create this new or this high value products. For us, it's always important that we create industrial use-able applications. So our clients has to use them in an industrial scale. And if a customer wants to do this, then at least as promised, you need 3 different processing steps. You need the Barter separator, you need a decanter, and you need the centrifuge or the Westphalia separator. With these 3 steps, you can gain directly de-oiled fish meat and cold press oil. And another application are possible. For example, out of the bones, you can, with a little bit further processing, you can create collagen, gelatin, calcium, and also pet food. So a lot of opportunities with just 3 well-known processing steps. Let me conclude a little bit what we have found out. We believe in 100% fish utilization. This project shows us that this is possible. We believe that we can bring co-products in a higher value as it is today. And we believe that we can create new products with high value out of co-products. And I said it already, only 3 steps was needed to do stuff like this. How we want to go on? The next step is we have to upscale the system. So we have test the system, as you see, in different application, in smaller scales at a customer, but also in test center from Gea, also already in an industrial field. We can also believe that we can use different types of fish, different species to do at least the same. And the next step will be that we bring this in a full integrated processing line of us. So we have to see how it works in a daily business. And here we believe that we have further optimization in regards of color, microbiology, and so on. And when we reach all of this, we are already able to take the next co-product to make the same agenda. Find out how we can gain more on the main product, find out how we can use this co-product in a different application, and let's find solution for it. Let me finalize with some words. I believe BARDA and GEA will be part of this development and try to help to reach the 100% utilization. And we know our response regarding the raw material, but also to feed this world to help to make 100% utilization. This is one important topic for our future, and we all have to work on this. If you have further questions, then you are more than welcome to get in touch with us. And if you have detailed questions, I also show us our experts. This is Dr. Pia Meinenschmidt from the BARDA side. She's food technologist and really an expert on this topic. And Dirk Zinnermann from GEA, who helps us to make this happen. Yeah, thank you for your attention. I hope this was interesting for you, and let's keep in touch. You are muted.
Okay. Thank you very much for your informative presentation. It was very thorough but of course, as always, a number of questions that will be interesting to raise. Unfortunately, time is not on our side, so I will if we have time, I would like to ask you some questions when following the presentation of our next speaker, which is Mehdi Abdullah, and he is a researcher at the Chalmers University of Technology in Gothenburg, Sweden. His major interests are within chemistry. They are associated with functionality and product forming capacity of alternative proteins. His research also focuses on developing innovative technologies and enabling holistic utilization of marine food resources. And the major area is extraction of proteins from seafood processing side streams using pH shift technology, which he has been working on since the beginning of his PhD back in 2012. Mehdi Abdullahi, the floor is yours.
Thank you very much. I hope you can hear me well. I'm going to talk a little bit about a different technology. You heard about enzymatic hydrolyzers. You heard about the mechanical separation from the border. But we are working on another technology which is called the pH shift technology. And again, we are trying to adopt this technology and tune it for 100% utilization of the seafood side streams. If you have the next slide. Yes, the challenge that has brought us all together today in this webinar is the increasing demand for the seafood products. Of course, if you look at this picture from 1975, each circle shows the consumption of seafood and the demand for different types of seafood products that we have in different parts of the world. You see the circles how much growing in 2015 compared to the previous year, and the demand will be so much into 2050. But where did so much seafood should come from? Of course, now it's coming from the wild capture and the aquaculture, which helps us to promote our production. But from the wild perspective, more than 80% of the resources are either fully or overexploited or fully fished. Aquaculture is doing well, but it again is dependent to the wild capture for feed and its own sustainability challenges that are there. Okay, where more seafood can come? which is the topic of our discussions today and the webinar that we are working on. If you look more carefully at the seafood production chain, we have been very much focused on the fillet, which results in 30 to 50% of the biomass that we enjoy eating. But about the side streams, it's 50 to 70% of the biomass that is not used perfectly today, I would say. It's not wasted in most cases, but in some cases it's still wasted. And the question is that how we bring them back into the value chain and use them as food. We already saw some technologies that enables us to make this happening, like the enzymatic hydrolysis and mechanical separation. But we are working on another technology. And I've spent almost all my research life on this technology together with Ingrid Underland here at Chalmers. What is this? Maybe you know, we can get the byproducts from different resources. We have studied a lot, these three resources that you see here, herring, cod, and salmon, which are the most available side streams in Scandinavia and Northern Europe at least. Then you mix them with water, the specific ratio, you can add alkaline base to them. You will get a soup system like this, and then you subject them to a centrifugation, a decanting or trecanting. Depending to the source that you bring in, you will get three different phases, nice fractionation. You will have the bone in the bottom, you will have the solubilized protein in the middle, and of course the fat which will float on the top. What is an emulsion? From a structural perspective, you will have a final purified destructured protein out of the system. This is the separation step. If we continue this process from the bottom that we did the fractionation, the liquid can go directly for example, as a coating for injection back to the fillet, range of application that allows us to use this fraction directly. But we can continue with the protein. We adjust their pH to isolytic point where they don't interact with water anymore. We do another centrifugation, dewater the protein, and we get a paste like this. It's the big advantage for this technology compared to the hydrolysis process, I would like to say, because you don't need drying here, which is the most energy intensive step in most of the food processing technologies. Then you can use it directly for production of restructured seafood products like burgers that we have made, the balls, the sausage. We have also tried it as a dried product if you need a highly concentrated protein from seafood side streams, and it can be used as an ingredient. We have tried it in different products. Huge application potential for the protein fraction, but this is not the end of the story. We have expanded the process to use almost everything coming in from this byproduct, as you saw for the batter technology. Here we have developed the technology to break down this emulsion at cold temperature. The process is patent pending now. And we are able to extract a very high quality cold press oil. Of course, the protein I explained, it can be used for different application, and we have developed technology to use the precipitate for collagen and collagen hydrolysis extraction. Like that, you can get much higher value addition from the side stream that you have, and taking care of almost everything in the side stream. Yeah, my first take-home message would be that PHE processing is also a very good alternative to fraction the proteins in a range of fraction the side streams to a range of products that can come back to the food value chain. And it has its own, as I mentioned, sustainability aspects, since we can skip the drying in the process, doing everything at low temperature, having very high quality product out of the system. There is no heating involved in the process, which is a big advantage. But the questions that are remaining, of course, the technology we have done a lot in the lab scale. We are doing a lot ongoing in the pilot scale. But we need to know how we need to have the complete value chain to be able to implement this process in the industry. And that's what we are following right now. For example, I'm trying to show here the side stream coming from the cod, for example, and you see you are dealing with a wide range of side streams coming from the single species. They are very different in terms of composition, the content of nutrients, and of course the content of peroxidants and sensitive fat. How this variation will affect the output of our process the process by itself, and so on and so forth. Another species in this case that we are following on the Vasili project is herring. And there we also have different types of byproducts. They come from the different seasons, the composition, the content of nutrients, the content of pro-oxidants will vary a lot depending on the resource. We have done extensive research on these two species right now, and we have tried to compare different type of side stream, their combination, and how would be the quality of the final protein and the production yield from this side streams. Here I have shown the picture of the protein isolates that are produced from this type of cod head, cod frame, cod plus frame, and viscera. And you see how much it impacts the appearance of the protein that you get. Here I'm trying to show how it will affect the production yield out of the process. There is not a big impact from the head, frame, or the combination. It's small differences, but you can get much more protein coming out from the viscera or gut, but you still lose a lot in the precipitation step. It means the type of the side stream will affect the process by itself and needs to be considered. But it's not the end of the story. When you go further, you see that the protein coming out from the viscera has no gel forming capacity, but in the other hand, the other proteins have gel forming capacity, but the quality of the gel is dependent again to the type of the side streams and the combination, and this needs to be taken into account. We have extensive results which will be soon published. You can follow it. We have done almost the same study for herring to see how the type of the side streams affect, the season effects, and we have done extensive analysis on them. I will not go into detail, but for example, you see that the lipid oxidation that can happen during the process is very much dependent to the type of the byproduct, and it is still a challenge that needs careful optimization. But we have developed a new technology which allows to stabilize the proteins by pre-treating the byproduct before the pH process. We pre-dip the side streams into some dipping solution, as we call it, that can be reused for 10 times, and the side stream can be afterward either stored or taken directly to the pH process. As you can see here, the blue line shows the protein isolate produced with the non-treated side stream, which is very unstable. After almost 2-3 days, you will have a high amount of lipid oxidation in it, but the pre-treated sample is stable for more than 14 days. And after 10 times reusing the dipping solution, still the sample is stable. It's the same for the secondary lipid oxidation product in this figure that you can see. But there are some side effects on the level of, let's say, the protein extraction yield. We have developed a second solution, which is still very effective, but the effect on the protein extraction yield is also mitigated. By that, I would like to finalize my speech and say that again, the technology is very promising. We are working on upscaling the process continuously, but the value chain also needs to be optimized. We need to take into account the combination of the side streams, the fish species, the sorting technology, especially for the herring, should be installed. We have done a lot in Sweden, and we are almost ready for that one. And the pre-dipping technology is also very promising to stabilize the proteins both during the extraction and after extraction process. Thank you very much to all of our supporters, funders, company partners, and of course my team leader Ingrid Underland and our collaborators. Yes.
Thank you very much.
You're welcome.
Thank you. Very interesting. One of the issue with proteins. Well, there are two questions I would like to ask you.
Yes.
One is regarding the proteins from fish in general. In what way are they different from proteins in other types of animals? Are they any better, or is there a difference in terms of health and so on. And secondly, one of the challenges that those who are utilizing proteins, for example, in protein pills and so on, is that there's the smell. How have you been able to manage and reduce the effect of smell in the way you are processing the proteins?
Yeah, thank you for your question. Regarding the first question, that are they better than other resources? There are a lot of, I would say, studies done that they have been very much focused in the animal studies, a little bit of the clinical studies that they have tried to compare fish resources with other resources to see whether they are better or not. In some cases, you see, for example, for cod, a lot on the fillet, protein from the fillet. They report that there are some better effects compared to casein. They have it's common to compare it. And I have recently written a book chapter, and I've tried to do an extensive review over them to see what is really standing out. And they see that the digestibility is slightly better at some point. The content of leucine that is sometimes a little bit higher. The taurine is a little bit, free amino acid is a little bit higher in seafood. Those are standing out in terms of content, in terms of quality of the protein that we get from the seafood. Makes them interesting source. About the second question, the fishiness and the fish odor, we have compared them very much with other typical resources. Let's say the fillet, to see if the quality of the protein hydrate that we get in terms of sensorial properties is better or it's worse. It's almost the same. Comparing to the other resources, let's say soy or other animal resources, I would say there is the fish taste, and I would strongly recommend that at least for now we keep the application limited to the seafood-based products.
Mm-hmm.
If you want to integrate this, for example, or put this into a product which the consumer are not expecting the seafood taste, no, it will not work.
Mm-hmm.
There is absolutely the fish taste, but if you dry it, it would be more challenges. But if you have it wet, the quality is much better. And having it in a burger, for example, no problem. But having it in a drink that the consumer does not expect the fish flavor, no, it will not work.
Okay. So we have some questions from the audience, and
To me or all the
well, I think it will be to all of the participants, yeah. And as I talked earlier about our time limits, I would like to get, ask a question, and then if you would just have a few words about and comments about the presentations of the others and the opportunities. We only have around 5 or 6 minutes to finish this off. Yeah. But we have a comment from David Russell, and he is addressing an issue which is, in my mind, a fairly general issue, but he is referring to Namibia for hake and monkfish, probably. It's the question of how we can encourage the producers, the fishermen, and so on, to bring everything ashore and to get them on this wagon of increased utilization, because we know that it is a challenge for those who have been processing the fish in a certain way for decades and so on, to enter new markets, and that, in a sense, to a certain way, we are asking the producers and the processors and the fishermen to bring their products into new markets which they are not very often familiar with. So, you know, if you're, like Frode was saying, into the pharmaceutical market, it's the market laws are very different than if you're selling a fillet. So I would just like to start with Frode, and then we would take Dennis and then Mehdi.
Well, I guess the solution is to help to get better margins for it. Cash is king. If they get paid for the products to get ashore, and then they will do it. Otherwise, it's irregulation, but we don't. I think it's better for us to help them take care of the byproducts, to store them in a proper manner, and perhaps as well we could do something on board. If you can take our technology on board in the ship, for instance, into a fishing vessel or a process vessel, we might utilize the ingredients ashore in a fresh manner. But it's all about margins. If you can, like all of us is like that. If you can get better margins than what we have done before, then we will do it. So you have to help them to get better margins from the process.
And what may I add to this? It's the freshness of the raw material. That is a huge issue, isn't it?
We believe so.
Yes.
If you can have it fresh material, we also will be able to do better end products. If you have harsh material into the process, we can't have high end products. Mm-hmm. We have to start with fresh material or frozen in a proper manner. It's quickly frozen down to a low temperature, then we can have the process afterwards. But good products in is also good products out.
Okay. Dennis?
I go with Frode as money makes the work go round, so this is an important topic, but I believe also that it has to be simple for the guys who use it. So we have to find systems where they can sort byproducts directly out or products out what they can't use on their own in the moment, and at least freeze them or chill them down so that we can use them in a later stage. So this is an important topic. But as most, we can help the companies to do it in a simple, maybe automated way, then they will use it.
Very good. Mehdi?
I totally agree with Frode and Dennis. Both the profit that they can get is important. Maybe in parallel, the legislation can help. The landing obligation in EU is an example. Companies are more interested to use everything that they capture. But at the same time, I think having this value chain approach is also important. If you are able in a country for a specific type of side streams or a type of raw material, have the whole value chain in place and developed, different actors will find their roles. And in this case, one part of the actors would be the fisheries man or fisheries fish capture responsible, that they will slowly find their way in the value chain, get paid, and due to dynamic into the value chain, they will in parallel, play their role. These things together should really happen and make things happening.
Very good. So we're getting to the end of this session. I just wonder whether there were any final words that you would like to just share with us, panelists. Frode, is there anything you would like to share with us in addition to what you already said and so on?
I think just a message that for the whole industry, both the ingredients industry and the fish processing industry, that we have to have food grade quality all the way, as high as and often as possible. So I think that's a common challenge for us all, to make sure that you have a good quality and a good treatment of the residuals.
Mm-hmm. Dennis?
I go this road. I believe we have a joint task here. So if we want to reach 100% utilization, no company in the world will do it on its own to make this happen. So we need the complete whole seafood industry to make this happen. So we need the supplier of raw material. We need companies like us as a manufacturer for machines. We need the development of new products, and we need also the end user who takes the product at the end of the day. So we need everybody in the line to make this happen. And for sure, we will also take our part of this.
Okay. Just one question, Dennis, regarding, because you are dealing with other types of industries than the marine resource industries. You are dealing with the meat and poultry and so on.
Right.
Do you find a huge difference in emphasis when it comes to 100% utilization between these different sectors?
I guess other sectors are a little bit closer to it, especially poultry industry is closer to 100% utilization. Also, meat industry is relatively go far on this road, and seafood is a little bit behind in this area. So we have to go on to fulfill.
And of course, that may be due to the fact that you're dealing with in many ways with a wild caught resource.
Yeah. Right.
Mehdi?
Yeah, I again totally agree with Dennis. We need the whole value chain, as I tried to highlight a lot in my talk. It's not only the technology, we need to complete the value chain for the side streams that we have. Again, in Bastivi that we have seen interviewing different companies, seafood producers, we have seen that lack of technology and lack of market for the final product is standing out as a necessity that we need to work on. Of course, we talk about the technology, but to really develop the market and put this nice product that is produced into the market needs further studies. We need to collaborate, test them into different types of products, either the conventional products that we have had or new products. So when we really make this, implement this technology in the industry, we have the market also in place. Imagine we want to use 1,000 tons of byproducts and we produce a lot of protein, where this protein should be really in the end use. That's also needs careful studies and work, and we need to work together again to make this happen.
Well, I think this has been a really valuable and informative session. I want to thank the speakers for a very good presentations. It will be possible to. We have recorded the event as I talked about in the beginning, and it will be possible. The recording will be uploaded to the IceFish Connect on-demand section of the platform. We will have another session where we are focusing on fish waste for profit tomorrow at 10 o'clock. And the focus tomorrow will be also on byproduct utilization, but from a different perspective. Before we end, I would like to remind all of those who are listening, wherever they are, that in 2022 we will have the Icelandic Fisheries Exhibition in Iceland, and hopefully we will be able to meet without being virtually meeting. And this exhibition will take place on the 8th and till the 10th of June in 2022. And of course, we will be welcoming visitors and exhibitors at the event. And I encourage people to contact the team at Mercator Media if they want, or visit the IceFish website if they need any further information and so on. But I hope all of you will have a good day, and I just, as I said earlier, thank the speakers for their presentations, And thank you very much and have a nice day.